This situation actually happened to me. I used to work in the semiconductor industry, and we had a clean room at our company. And a clean room is basically a room where the air is filtered and pushed gently in from the ceiling. And you have a raised floor. So you're walking around on a floor that has lots of little holes in it, and the air very gently goes through the room and out through the holes in the floor, and then it returns. It gets filtered, and after it gets filtered, it gets pushed back in the top, and it keeps the room very clean. Basically, you're working in the very clean environment that way. So one morning I came into work, and one of our pieces of equipment had developed a water leak. And I popped a couple of these floor tiles out, and I started looking around underneath the floor tiles, and basically there was a swimming pool there that had filled up. This area underneath had filled up with water. And I looked, and I knew that there was a speaker in the middle of the floor that hooked up to the company PA system, so we could hear announcements and things when we were in the clean room. And I started looking for it, and I couldn't see it. Because basically, let me see, I'll draw it in blue here. When I was looking towards the speaker was right in the center. When I looked directly in that direction, when my line of sight hit the water, it would, of course, the direction would change, and there was no speaker here. So I'd look out a little further, and the line of sight would get deflected. There was no speaker there. And I had to look clear out to the other end of the clean room so that my line of sight would see the actual speaker. It was very interesting illusion that looked like the speaker had moved clear to the other side of the room. Of course it hadn't. It was right where it always was. But very strange when you have to look clear to the other side of the room to see something that's right in the center. Okay, I've cleaned up my sheet here a little bit. Let's work on solving this problem. We know that we have to look out 7 meters from where our eye is to see the apparent location of the speaker. But we know the speaker is actually much closer to us, and I'm calling that distance y, and that's what we're solving for. So the first thing I'm going to do is use this large triangle from my eye to the apparent location of the speaker. Let me just draw that here. My eye, the apparent location of the speaker. So this side is 7 meters. And this side is 0.8 meters. And we need to find this angle. I'm going to call that, I'll just call that theta. And so what do we know? We know that the theta is going to be the inverse tangent of 0.8 over 7. And that gives us 6.52 degrees. And the reason that's important, because that is the same as this angle right here. That's theta. That means that this is also theta. But what we really care about is this angle. I'm going to call that theta 1. And then this angle in here, which I'll call theta 2. So if this is theta, then theta 1 is going to be 90 minus that, and we get 83.48 degrees. So I'm going to redraw what's happening right at that interface there. And we've got the water line, and our location of our speaker is right about here. and we're coming in at a glancing angle, and then it bends down. This line's not very good. How's that? A little better? So we know this angle, I'm going to call it theta 1, 83.48 degrees. We're calling this theta 2. Our eye is located right over here. So this distance is actually what we're looking for, right? The distance y. But let me call this distance here x, and this will be y minus x. I think that'll help us a little bit. So what do we know about this problem? We know that n1 times the sine of theta 1 is going to be n2 times the sine of theta 2. And we know in this case n1 is equal to 1 because we have air above the water, and n2 is 1.33 because that's water, and we know theta 1, so we can solve for theta 2. .3 degrees. Now we have to do a little geometry. We can look at this situation one more time, and we know a couple of things. If we're just looking at this part of the problem here, I've circled in blue, then that's going to give us the tangent of theta 2 has to equal x over this height, which was 0.5. And so that enables us to solve for that distance x. I got 0.562 meters. And if we look at this part of the problem, I'll use green for that. That tells us that the tangent of theta 1 is going to be this distance, which is y minus x, over 0.3. And that tells me that y minus x is 2.625 meters, or y is 3.187 meters. So basically, just a little geometry there. Once you've got the first part of the problem, the physics is basically done, and then it's just a geometry problem. But I end up with the actual location of the speaker. Let me go back and mark it up here. The actual location of the speaker being 3.187 meters, even though it looks like it's all the way down here at 7 meters.